So today we're going to talk about how to solve absolute value equations, and we have our steps up here at the top of our paper. But before we really dive into those steps, it will make more sense if we first review the definition of what absolute value means. So remember, absolute value means the distance from zero a number is on a number line. So we have 6, which is 6 units away from 0, and we have -6, which is also 6 units away from 0. So that's why the absolute value of 6 is 6, and the absolute value of -6 is also 6, because absolute value just means the distance a number is away from 0 on a number line. So looking at example 1, what two numbers can I substitute in for x so that when I took the absolute value of those two numbers, it would equal a positive 2? Well, I could let x be 2, or I could let x be -2. And in both of these situations, when I plug each of these numbers in one at a time, if I took the absolute value of 2, I would get 2. And if I took the absolute value of -2, I would get 2 again. So we can write our answer like this. We can write our answer like this. And the way that the instructions ask us to write our answer is using set notation, so that looks like this. Okay, these are just curly braces. They denote that we have a set of two answers. Our two answers are 2 and -2. So the next one we'll do is number 3. Notice that I have more than just x inside absolute value. So what I need to do here is I need to make two cases. I need to make two cases. My first case is where 5z equals 40. And my second case is where 5z equals -40. Now, if you take just a minute to reflect back on what we did for number 1, we actually did the same thing here. We found two cases. We have x equals +2 and x equals -2 as our two cases. So for this problem, I'm starting the same way, the exact same way that I started number 1, only this time after I make my two cases, I see that I haven't exactly solved for z yet. So what do I need to do in order to solve for z? So in order to solve for z for both equations, I need to divide both sides by 5. So when I divide the first equation by 5, I get z equals 8. When I divide the second equation by 5, I get z equals -8. So in solution set, it doesn't matter what order you put the numbers in, but you should have something either z equals -8 and 8, or z equals 8 and -8. So the next one I want to do along with you is number 6. So I'm going to start the same way. We always start our absolute value equations by making two cases. W minus 3 equals 4 and W minus 3 equals -4. Notice that every time I have worked these problems, every time I set up my two cases, the only sign that changes is the sign on the answer side. So the only sign that has changed is the sign on the answer side. I did not change the negative in front of 3 to denote -3. The only sign that I changed is right here in front of 4. 4 became -4 in the second case. So from here, I need to solve for W, and I need to do the same step in both equations. In order to do that, I need to add 3 to both sides for both equations. So for my first answer, I need to add 3 to +4. 4 plus 3 is 7. And for the second answer, I need to add 3 to -4, which results in a -1. So our solution set answer, 7, -1, or 1, or -1, 7. Okay, the next one we're going to do is number 8. So I start the same way. I have the absolute, I'm breaking out of absolute value. I have 2 different cases. Nothing is going to change between the original and the cases that I'm setting up, except for the answer side here. Okay, so I just write the same exact equation once. Then when I write it the second time, the only part that changes is the answer side switches to a negative number. So from here, for both equations, I need to start by adding 5 to both sides. So negative 2v equals 22, and negative 2v equals negative 12. Then to finish solving, I need to divide both sides of both equations by a negative 2. So v equals negative 11, and v equals 6. So to write my answer as a solution set, I'll say v equals, curly brace, negative 11, comma 6.